ZV Academic Services, the best and finest academic services in the world. Now, I've been asked by my students today to look at chemistry grade 12. Okay, and the question that we are being asked today is construct a balanced chemical and net ionic equation for the reaction between potassium hydroxide and sulfuric acid, and then you include state symbols. So we have to find the chemical equation, and then we also find the net ionic equation. Now, for the first part, we have to understand that this reaction, the reaction that we have for the first part, the reaction that we have potassium hydroxide plus the sulfuric acid. Now, what we get is, we don't know what we get, but we should understand that this reaction, when we look at this is potassium hydroxide. The potassium hydroxide is a base, okay? And then when you look at sulfuric, this is sulfuric acid. When you look at sulfuric acid, this is a base, and then this is sulfuric acid. So we have a base plus an acid, okay? What we are expecting to get is salt plus water. Okay, His Excellency would say water. Okay, so we have base plus acid, and then what we get is just salt plus water. Now, the base is potassium hydroxide, and then I'm going to write potassium hydroxide as potassium hydroxide, which is in aqueous. Okay, and then plus we have sulfuric acid. Okay, we know the chemical formula for sulfuric acid is just H2 and then SO4, which is also in aqueous. Okay, and then what we get now is a salt. Now the salt is potassium sulfate. Okay, meaning that we get potassium sulfate, which is a soluble salt. So I'll put aqueous. Okay, plus water, which is just the H2O, and then we'll put liquid there for the state symbols. So we have potassium hydroxide in aqueous, and then plus sulfuric acid, which is also in aqueous, and then you get potassium sulfate, which is in aqueous, and then water. Now we should balance this chemical equation. How do we balance this chemical equation? Because when you look at this, we have 2 atoms of potassium, and then here we have 1 atom of potassium. So I'm going to put 2 here, okay? So that we have 2 and then 2 atoms of potassium, and then we also have 2 atoms of potassium. Okay, and then this side we have 2 atoms of oxygen, and then plus 4 atoms of oxygen. So we have 6 in total on my left hand side. And then this side I have 4 atoms of oxygen, and then I have 1 atom of oxygen. So if I put a 2 here, I have 4 plus 2 atoms of oxygen. What we get is 6. Okay? Okay, and then I have 2 atoms of hydrogen plus 2 atoms of hydrogen. What I get is 4 atoms of hydrogen in total. And then this side I have 2 times 2, I get 4. So 4 atoms of hydrogen. Now I look at sulfur, which is the last one. Sulfur, I have 1 atom of sulfur, and then I have 1 atom of sulfur. So this is balanced. Okay? So this is balanced. Are we together?
Yes.
Okay, so this is balanced. So this is for the first part. Now the second part, we are saying that we should write the net ionic equation. Okay, for the second part, we write the net ionic equation. Now, how do we write the net ionic equation? So we're going to use the same equation, chemical equation that we have been given, the one that we just found, and then we only write ionic equation of those compounds or ions that are in aqueous state. Are you following?
Yes.
Okay, because those are the ones that can dissociate. Those are the ones that can ionize. Okay, so like this one, we'll say for the first part, which is potassium hydroxide, we know that we have 2, okay, potassium ion, which is in aqueous, okay, plus 2 moles of hydroxide ion, which is also in aqueous, okay, and then we have plus 2 moles of hydrogen ion, which is also in aqueous, plus we have sulfur ion, the sulfate, so a sulfate ion, which is also in aqueous. And then what we get now this side is we have 2 moles of potassium ion, which is in aqueous, okay, plus the sulfate ion, which is also in aqueous, and then plus 2 moles of water, and then this is just in liquid.
So, now, sir, a question. Are we having 2 moles of hydrogen ions? Is it not supposed to be 2? Is it not supposed to be 1?
Where?
On the sulfate. Now the hydrogen ion.
On this one?
Yeah.
Okay, so on this one, look at this. Okay. We look at this. This is here. When you look at this, we have 2 atoms of hydrogen. Okay. No wonder when we are balancing, we are saying that this is representing 2. Okay, and then this is also representing 2. Are you following? Okay. So now this 2, it's the one that we include as the number of moles. Are you following?
Yes.
In terms of the mole ratio. I don't know if you understand. In terms of the mole ratio.
Okay.
Okay. Are we on the same page?
Yeah.
Okay. So in terms of the mole ratio, we have 2 because we have 2 atoms of this hydrogen. Okay, we have 2 atoms of hydrogen. Okay. I don't know if I'm clear.
Yeah, clear.
Okay. So now we proceed. Okay. Thank you for that question. It's a very good question. So we proceed. Look at this. So we need to get rid of those ions that are just spectators, okay? Those ions that are not taking part in this chemical reaction. And these ions we have, when you look at this side, we have, okay, this is 2 atoms, or 2 potassium ion. And then this side we also have, this is potassium ion. Are you following?
Yes.
Are you following? Okay, and then this side also we have, you look at the sulfate ion. Okay, the sulfate ion, and then also the sulfate ion. We get rid of these sulfate ions. Okay, is there anything that we should do? Get rid any ion that is a spectator, that is just is not taking part in this chemical reaction? Okay. Any? Okay, so these are the only ones that are involved in this chemical reaction. Are you following?
Yes.
Okay. Can I rub this part?
Yes.
Is it this part or this part?
The solution part. Solution part.
Okay, now we are moving from this part to this part. So on this part we have 2 moles of hydroxide ion, which is in aqueous, okay, plus, and then I come to this one here, we have 2 hydrogen ion, okay, which is also in aqueous, and then this gives us
excuse me, sir, I cannot see clearly.
We are here.
Yeah.
Okay, so here we have, let me just write it properly now. Okay, so this is the hydroxide ion. Okay, so we have 2 moles of hydroxide ion, that is in aqueous, plus 2 moles of hydrogen ion, which is also in aqueous. And then we get, this side is just water, okay, which is in liquid. Are you following? Yes. Now when you look at this one, the mole ratio just 2, 2, 2. So we can simplify this one by saying 2, 2, 2. It's the same as saying 1, 1, 1. Are you following?
Yes.
Okay, because we can simplify these ones, okay, giving us 1. So this is just the same as saying the hydroxide ion, which is in aqueous, plus the hydrogen ion, which is also in aqueous. This gives us water, which is just in liquid. Vamveka?
Yes.
Vamveka?
Yes.
Okay. Finally, this is or eventually, this is what we get. Okay. So we have just the hydroxide ion in aqueous plus the hydrogen ion, which is in aqueous, and then we get water as the final answer. Okay. See you next time, and don't forget to subscribe to our YouTube channel, KZV Academic Services. Thank you.